History of computer generation. Let's learn about generation of computer, classification by capacity, classification by their basic operating principle. As the time passed, a more suitable and reliable machine became a need which could perform our work more quickly. Computers are such an integral part of our everyday life that now most people take them and what they have added to life totally for granted. Even more so the generation who has grown from infancy within the global desktop and laptop revolution since the 1980s. Generations of computer. The history of the computer goes back several decades. However, there are 5 definable generations of computers. Each generation is defined by a significant technological development that changes fundamentally how computers operate, leading to more compact, less expensive, but more powerful, efficient and robust machines. First generation of computer, 1940 to 1956.
The computers manufactured between 1940 to 1956 were called first-generation computers. They were extremely large in size with vacuum tubes in their circuitry which generated considerable heat. Hence, special air conditioning arrangements were required to dissipate this heat.
They were extremely slow and their storage capacity was also very less compared to today's computers. In these computers, punch cards were used to enter data into the computer. These cards with rectangular holes punched in them by using some punching devices. UNIVAC 1 was the first commercially available computer built in 1951 by Remington Rand Company. It had storage capacity of about 2000 words. These were used mostly for payroll, billing and some mathematical computing.
Second generation of computer, 1956 to 1963. The computers in which vacuum tubes were replaced by transistors made from semiconductors were called second generation computers. The use of transistors reduced the heat generated during the operation. It also decreased the size and increased storage capacity. It required less power to operate and were much faster than first generation computers. Magnetic media was being used as an auxiliary storage of data. These computers used high-level languages for writing computer programs. Fortran and COBOL were the languages used.
Third generation computer, 1964 to 1971. The third generation computers started in 1964 with the incorporation of integrated circuits, IC, in the circuitry. IC is an monolithic circuit comprising a circuitry equivalent to tens of transistors on a single chip of semiconductor having a small area, a number of pins for external circuit connections. IBM 360 series computers in this generation had provision for facilitating time sharing and multi-programs also. These were small in size and cost-effective computers compared to second-generation computers. Storage capacity and speed of these computers increased many-fold as it included user-friendly package programs, word processing, and remote terminals. Remote terminals could use central computer facilities and get the result instantly. Fourth generation of computer, 1971 to present. Fourth generation computers were introduced in 1971, and in these computers electronic components were further minimized through large-scale integration techniques. Microprocessors, which are programmable ICs fabricated using LSI technique, are used in these computers. Microcomputers were developed by combining microprocessor with other LSI chips. With compact size, increased speed and increased storage capacity. In recent days, ICs fabricated using VLSI very large-scale interrogation techniques are used in computers. Though these techniques, the storage capacity is increased many-fold. Not only that, the speed of these computers is also very high as compared to earlier computers. During 1980s, some computers called as supercomputers were introduced in the market. These computers perform operation with exceptionally high speed, approx 100 million operations per second. This speed is attained by employing number of microprocessors consequently. Their cost is also very high. These are normally used in very complex applications like artificial intelligence, etc. Fifth generation of computer, present and beyond. Computer devices with artificial intelligence are still in development, but some of these technologies are beginning to emerge
and be used, such as voice recognition.
AI is a reality made possible by using parallel processing and superconductors. Leaning to the future, computers will be radically transformed again by quantum computation, molecular and nanotechnology. The essence of fifth generation will be using these technologies to ultimately create machines which can process and respond to natural language and have capability to learn and organize themselves. Leaning to the future, computers will be radically transformed again by quantum computation, molecular and nanotechnology. The essence of fifth generation will be using these technologies to ultimately create machines which can process and respond to natural language and have capability to learn and organize themselves. Classification by capacity. Computers can be classified according to their capacity. Computer capacity is currently measured by the number of applications that it can run rather than by the volume of data it can process. This classification is done as follows. Microcomputers. The microcomputer has the lowest level capacity. The machine has memories that are generally made of semiconductors fabricated on silicon chips. Large-scale production of silicon chips began in 1971, and this has been of great use in the production of microcomputers. The microcomputer is a digital computer system that is controlled by a stored program that uses a microprocessor, that is, a programmable read-only memory, ROM, and a random access memory, RAM. Mini-computers. In the 1960s, the growing demand for a smaller stand-alone machine brought about the manufacture of the mini-computer to handle tasks that large computers could not perform economically. Mini-computer systems provide operating speed and large storage capacities than microcomputer systems.
This type of computer system is very flexible and can be expanded to meet the needs of users.
Medium-sized computer. Medium-sized computer systems provide faster operating speed and larger storage capacity than mini-computer systems. They can support a large number of high-speed input or output devices. Several disk drives can be used to provide online access to large data files as required for direct access processing, and their operating systems also support both multiprogramming and virtual storage. A medium-sized computer can support a management information system and can therefore serve the needs of a large bank, insurance company, or university. They usually have memory sizes ranging from 32K to 512K bytes. The IBM System 370, Burroughs 3500 system, and NCR Century 200 system are the examples of medium-sized computers. Large computers. Large computers usually contain full control systems with minimal operator intervention. Large computer system ranges from single processing configuration to nationwide computer-based networks. They have storage capacities ranging from 512K to 8192K bytes. In these computers, The internal operating system is measured in terms of nanoseconds, whereas in small computers, the speed is measured in terms of microseconds. Supercomputers. The supercomputers are the biggest and the fastest machines today, and they are used when billions or even trillions of calculations are required. These machines are applied in nuclear weapon development, accurate weather forecasting, and as host processor for local computer and time-sharing networks.
Supercomputers have capabilities far beyond even than the traditional large-scale systems. Their speed ranges from 100 million instructions per second to well over 3 billion. Examples of supercomputers are Cray 2, Cray XMP24, NEC 500. Classification by their basic operating principle. Using this classification technique, computers can be divided into analog, digital, and hybrid systems. They are explained as follows. Analog computers. Analog computers were well known in the 1940s, though they are now uncommon. In such computers, numbers to be used in some calculation were represented by physical quantities such as electrical voltages. According to the Penguin Dictionary of Computers, 1970, an analog computer must be able to accept inputs which vary with respect to time and directly apply these inputs to various devices within the computer, which performs the computing operations of addition, subtraction, multiplication, division, integration, and function generation. The computing units of analog computers respond immediately to the changes which they detect in the input variables. Analog computers excel in solving differential equations and are faster than digital computers. Digital computers. Most of the computers today are digital. They represent information discretely and use a binary, two-step system that represents each piece of information as a series of zeros and ones. The Pocket Webster School and Office Dictionary, 1990, simply defines digital computer as a computer using numbers in calculating. Digital computers manipulate data more easily than analog computers. They are designed to process data in numerical form, and their circuits perform the mathematical operations of addition, subtraction, multiplication, and division directly. Because digital information is discrete, it can be copied exactly, but it is difficult to make exact copies of analog information. Hybrid computers. Hybrid computers are the machines that can work as both analog and digital computers. Such computers are used in medical and surgery.